This video focuses on analyzing problems that involve rectilinear or straight line motion. Only examples of linear motion with constant velocity or with constant accelerations are tackled in this discussion. This includes the motion of a freely falling body. So stick around, watch and learn. Our question number 1. A typical male sprinter can maintain acceleration for 2.0 seconds and his maximum speed is 10.0 meters per second. After he reaches this maximum speed, his acceleration becomes 0 and then he runs at constant speed. Assume that his acceleration is constant during the first 2.0 seconds of the race, that he starts from rest, and that he runs in a straight line. Question letter A. How far has the sprinter run when he reaches his maximum speed? Question letter B. What is the magnitude of his average velocity for a race of 100.0 meters? In answering question letter A, we first determine the average acceleration of the sprinter when he started running from an initial speed of 0 and until the time when he attains his maximum speed of 10.0 meter per second. Okay, this happened within a time of 2.0 seconds. Alright, so from that formula, A is equal to V final minus V initial, then divided by the time t, we have 10.0 meter per second. That is the maximum speed that the sprinter attains in a time of 2.0 seconds. So therefore, the average acceleration is equal to 5.0 meter per second squared. And then, using the formula d is equal to 1 half at squared, okay, that will now lead us to the distance run by the sprinter, all right, starting from rest until he reaches his maximum speed of 10.0 meter per second. All right. So d is equal to 1 half the acceleration multiplied by the square of the time. Substituting, we have 1 half of the calculated average acceleration, which is 5.0 meter per second squared, and then multiplied by the square of the time, 2.0 second. And we will get the distance traveled equal to 10 meters with two significant figures. All right, so moving on to question letter B. We are to determine the average velocity of the sprinter in running the 100 meters. All right, take note that he is competing in a 100 meter dash. We have to determine first the time for him to run the remaining 90 meters. All right, because he has already run 10 meters, okay, within 2 seconds. Therefore, he has a remaining distance of 90 meters, and that he is going to complete this race by running with a constant speed that he acquired after 2 seconds, and that is at a constant speed of 10.0 meter per second. So that time, all right, is equal to 9.00 seconds. And so therefore, to determine the average velocity of the runner, of the sprinter, we just use the formula V average is equal to the total distance divided by the total time. Substituting, the total distance, of course, is 100.0 meters divided by the total time, all right? The total time here is from the start until he reaches the finish line. And that total time is, of course, the sum of 2.0 seconds and 9.00 seconds, which is 11.0 seconds, for an average velocity of 9.09 meters per second to three significant figures. So again, to emphasize, the answer to letter A is in the first 2 seconds, starting from rest until he attains his maximum speed of 10.0 meters per second, the sprinter traveled 10 meters. All right. And answer to letter B, the average velocity of the sprinter in running the 100-meter dash race, his average velocity is 9.09 meters per second. Question number 2. The engineer of a passenger train traveling at 25.0 meters per second sights a freight train whose caboose is 200 meters ahead on the same track. All right? The freight train is traveling at 15.0 meters per second in the same direction as the passenger train. So, before I continue, here's our sketch. All right? So this is the passenger train, which initially is traveling at 25.0 meters per second. All right? So at that instant, the engineer, all right, sees a freight train 200 meters ahead on the same track. So there's the freight train traveling at a slower speed, all right, 15.0 meters per second, but traveling in the same direction as the passenger train, right? So, uh, the engineer of the passenger train immediately applies the brakes, right? At that instant, when he sees the freight train 200 meters ahead of him, all right, he applies the brakes, causing a constant acceleration for the passenger train, and this acceleration is equal to 0.100 meter per second squared in a direction opposite to the train's velocity. This means that the passenger train should decelerate, all right, or accelerate negatively, meaning the passenger train has to slow down to avoid a possible collision with the freight train. All right. The freight train, all right, continues to move ahead with constant speed. All right. And taking the x equals 0 at the location of the front of the passenger train when the engineer applies the brakes. All right. So for our computation in a short while, we will use that point at the location of the front of the passenger train when the engineer applies the brakes. So that will be our reference, x equals 0. Question letter A is asking for, will the cows nearby witness a collision? And question letter B, if there is a collision that will happen, where will it take place? So the reason why we emphasize that x equals 0 will be our reference, all right, so that we can answer question letter B perfectly well. And you will have the detailed solution for this problem in just a short while. Our solution to this question, we are predicting that there will be an inevitable collision based on the fact that the passenger train is traveling at a much faster speed of 25.0 meter per second as compared to the freight train traveling only at 15.0 meters per second. Okay? And considering that the deceleration of the passenger train is rather small, it is only 0.100 meter per second squared. And the other consideration is the fact that the freight train is only 200 meters, okay, along the same track in front of the passenger train. So there is a big possibility for the passenger train to really collide with the freight train, assuming that the freight train will not speed up any further, right? So we will only base our prediction from the data that are given in this problem. All right. So first thing that we have to determine is to find the time for the two trains to collide. All right. So we will let the quantity small t be the time for the two trains to collide. All right. And we will also let small letter d be the distance traveled by the freight train. Remember, the freight train is not going to slow down or change its speed. All right. It just continues, and in as much as the passenger train is still 200 meters behind, okay, uh, it's pretty sure that the freight train will still be able to travel a certain distance, all right, a certain distance d until it will be crushed by the passenger train. So we want to calculate for that distance d. Now, that distance d can already be expressed in terms of the constant speed of the freight train, which is 15.0 meters per second, and multiplied by the time t. All right. So from that instant when the freight or when the passenger train started to slow down, all right, uh, assuming that the freight train is going to be hit, so during that same time interval, all right, the freight train will be covering a distance d, and that is expressed as its average speed of 15.0 meter per second multiplied by the time t, which is still undetermined. So we will just let the time t as is. Now, for the passenger train's motion, all right, we will use the formula in determining the distance traveled by a body that is accelerating at a certain initial speed, okay, for a given time elapse and with a given value for its deceleration, right? So, if d small d is the distance that will be traveled by the freight train, right? When we add that distance to 200 meters, this total distance that will be covered by the passenger train, all right, that will be, of course, the total distance that the passenger train will be traveling when it starts to decelerate at an initial speed of 25.0 meter per second, all right, for whatever that time elapsed small t would be. And of course, to be deducted from that is the value of 1/2 its acceleration or deceleration and the square, multiply that by the square of the time elapsed. So as you can see, in this particular equation, considering the motion of the passenger train, we have the two unknown quantities, all right, the distance d and the time elapsed, small letter t. But since we already expressed d as the product of 15.0 meter per second multiplied by that time t, we can just substitute that with what we have here in this equation, all right? So that is what we will now consider. 200, all right? Forgetting about the units for simplicity, so this becomes 200 with three significant figures. Notice that I put here a decimal point, okay, to emphasize that 200 here has three significant digits, plus, all right, uh, the value for d, which is already expressed as 15.0 multiplied by t, and then equal to 25.0 times t minus, the reason why it is minus is that the passenger train has a negative acceleration, all right? So, without using a plus sign and then putting a negative sign to the value of a, we just do it this way, minus 1/2 the acceleration 0.100, all right, and then to be multiplied by the variable t squared. So in this equation now, we only have one unknown quantity, and if you're going to simplify this, all right, we will come up with a quadratic equation, all right, already simplified, t squared minus 200t plus 4,000 equated to 0. All right, so this is our working equation to determine the time elapsed t. In just a short while, we'll be using the quadratic formula to determine the value of the time elapsed t. So our derived quadratic equation for determining the elapsed time t, t squared minus 200t plus 4,000 equals 0. And using the quadratic formula or quadratic equation formula, all right, when we substitute, t will be equal to 200 plus minus the square of 200 minus 4 times 1 times 4,000, and then all of the quantities inside the bracket will be divided by 2 times 1, or 2. All right. So we will come up with two possible answers for the value of t. The first one, where we add 200 plus whatever comes out as the square root of the quantities inside the radical sign and then divided by 2. All right. We will get a certain number, okay, for the elapsed time t. But here we choose the second one, where the result of getting the square root of the quantities inside the radical sign will be subtracted from 200 and then later divided by 2. And that number or time elapsed will be equal to 22.5 seconds. We choose this over the other one, the first one, because logically, okay, this answer of 22.5 seconds is the lower value for t. The other possibility is when we get a much larger value for the time elapsed. And we prepare this one because this is what is more appropriate, you know, in the situation, right? So with this computed time elapsed 22.5 seconds, we can now determine the distance traveled by the freight train, all right, which is earlier we said that that distance is equal to 15.0 meter per second, the average speed of the freight train to be multiplied by the computed time elapsed, all right, and we get the value for the distance traveled by the freight train equal to 338 meters. All right, now this time elapsed of 22.5 seconds is also the time for the passenger train, all right, when it started to apply, when the, what do you call this, when the engineer of that passenger train started to apply the brakes until the time when it collides with the freight train, okay, the time elapsed, of course, is also equal to 22.5 seconds. But since initially the passenger train is 200 meters behind the freight train, so in answer to the question, where will the collision takes place, all right, we simply add 200 meters to the calculated distance d of 338 meters. Therefore, our final answer is that the collision will occur at a distance of 538 meters from the reference point, which we earlier assumed to be equal to 0, x equals 0. This is the reference point that we considered, okay, representing the starting point of the passenger train when the engineer first sights the freight train 200 meters uh, down the railway. All right, so therefore the final answer is that the cows will be able to witness a collision between the passenger train and the freight train happening at a distance 538 meters from x equals 0. For our last question, question number 3. You are on the roof of the P6 building, 46.0 meters above the ground. Right? So this is our sketch. This is the P6 building, 46.0 meters tall. You are there on the roof. All right. Your physics teacher or professor, who is 1.80 meter tall, is walking alongside the building at a constant speed of 1.20 meters per second. If you wish to drop an egg on your professor's head, where should the professor be when you release the egg? Assume that the egg is in free falling or is in free fall. Use the value for g equal to 9.80 meters per second squared. So, um, our target variable is to determine the distance small d. This represents the horizontal distance between the point where the professor should be, okay, at the instant when you drop the egg, all right, the professor should be at that point, okay. The horizontal distance between the point where the professor should be and the point on the ground exactly below you, all right. So that is what we're going to determine in a short while. Our solution to this question, we'll find the time small t of the dropped egg to travel a distance each equal to 46.0 meters minus 1.80 meters, which is 44.2 meters. All right? Why do we deduct 1.80 meters from 46.0 meters? This 1.80 meters is the height of the professor, and the height of the building is 46.0 meter. So the drop egg, okay, will travel a distance which is the difference between these two. That is 46.0 minus 1.80 meters, or 44.2 meters. And then we will determine the time, small t, for the egg, okay, to travel that distance, 44.2 meters. Formula for that, of course, is t equals square root of twice that distance h divided by g, where the initial velocity of the egg is understood to be equal to 0, so it starts from rest. Substituting our data, square root of 2 multiplied by 44.2 meters, and then divide by the value of g, which is 9.80 meters per second squared. Doing our math, we will get time t equal to 3.00 seconds in three significant figures. Right. And then we can now find the horizontal distance d, or target variable. The horizontal distance d walked by the professor, right? Remember, the professor is walking at a constant speed, okay, towards the point where the egg is supposed uh, to fall, right? So, since the professor is moving at a constant speed v, you just multiply that by the computed time t of 3.00 seconds. His constant speed while walking is 1.20 meters per second, right? Times 3.00 seconds. So the distance walked by the professor before he is hit on the head, okay, by a falling egg would be 3.60 meters, right? So that is the answer to the question. Whatever happens next, okay, it's up to the professor what disciplinary action he will take against you. So that's it. Thank you very much for your indulgence. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.